Morning, guys. Welcome to another episode of Xa Talk Show. Today is 2019, November 16th, Saturday, and 1 o'clock p.m. in the afternoon. Hello, beautiful people. Hello, Bart. How are you guys? So, how many people do I have? 6 people. Not many. I'm actually tired. I slept 4 hours yesterday. So, okay, concurrent viewers now dropped to 4. I'm kind of tired. So today, is Alan here? We are supposed to do JavaScript and mathematics. Am I alive? Yes, I am alive. Okay, so hold on a second. I need to turn off my laptop over there. My junk. So what you guys up to? Hello, beautiful people. Hello, beautiful people. So, what are we talking about? I'm thinking, the plan was to do mathematics to continue yesterday's polyhedra. We were drawing polyhedron, so let's show it. Showing Chrome, but I'm kind of tired, so I don't know if I can do well when talking about technical stuff today. So I'm thinking maybe let's just do random, like random chat. Hello, beautiful people. So, how are you doing? So Bart had some questions. I don't know what you're doing, Bart. I don't know. If you have a question you really need to solve, just post question. Post the error messages. Get it solved. Like, do you want? Like, what is your intention? Like, you got a problem. You need help. You want it solved or not? Or you just want it's a topic to talk about, to joke about. Hey, good morning, Zitron Crazy. uh, so I mean, Bart, so you are trying to install this batshell. Okay, I didn't know what that is. Okay, so before I thought you mean bash. Then after a few days ago when you guys were mentioning that, I thought you guys means bash. Okay, then good morning, Kathy. Okay, I started to have people coming in. Now I need to do a good show. Oh God, now it becomes a responsibility. So there is this, I guess, new tool, okay, called batch, which is idiotic. So people, Bart and other people has been talking about it a few days ago. I didn't get it. I thought they mean bash. I thought there's a joke somewhere. And then after the video, I thought it means bat shit, like bash, like bash is bad shit. Okay, I didn't get it. But today, Bart is, he's saying he's got a problem. Uh, he's got a problem. So apparently, so there is this tool, okay, called batsh. Now, what it does is it's a kind of a new language. The purpose of this language is that you can write in this language so that it will compile into both bash and Windows batch script, because both bash and batch are very problematic because they are very old, 20 years of baggage. So apparently this bat shell is meant to solve that problem. So you write shell script intended for Linux or Windows batch. So you write in batch shell, then you can compare it to both. That seems to be the intention of this scripting language, this shell. And it is written in this wondrous language, ocaml, functional programming language, which is also meta language, which is also fsharp, which is also camel, which is also um, you know, and Haskell borrowed. Basically, Haskell is somewhat a derivative of it. So ocaml, and it's practical. It's used. It's very widely. It's much more popular than Haskell, even before Haskell was known 10 years ago. So it's written in OCaml, okay? So in order to install this batch, you need to install this opam, the OCaml, some tool in OCaml and install OCaml. And okay, so I don't know. Let's look at the syntax. Okay, I think this is crap. You don't need it. But like I can tell you right away, you don't need it. Just unless you are working, this is my guess. Like I don't know much about you, but my guess is pretty much you are yak shaving. That's what you are doing. That well, yeah, I don't know. Okay, I don't know what you are saying. I don't know what's your situation, but that's my guess from what I of seeing of you. You don't need it. But anyway, unless you are working in a company like A25, like you work in a company, and your company has 100,000s of lines, you need to build a system, that needs to have the script working both Windows and Bash on Linux. And even in that case, I don't think you don't need they will not use it. Okay, I can tell you from my experience. I don't know for sure because I haven't actually worked in such a company with such a need. But from my experience, I can tell you right away. Those companies, who has maybe millions of lines or some critical system where they need to deploy on both Windows and Linux, they need a shell script that works on both. They will not use this bad shit. Okay, I can tell you right away. So I don't know what is your reason, but where are you doing this? Okay, I don't know. But maybe you find this language interesting or something. Okay, so I don't know. But even so, Kathy, do we have a topic? Kathy and Zitron. Okay, let me ask you some other guys because right now I'm just rambling. And hello, beautiful people. I'm because I'm kind of tired today. But do you guys have a topic? So anyway, back to the batch. So I don't think people are using this. Okay, it's somewhat popular. 3.9 thousand stars. Oh, okay. When is this created? Oh, 6 years ago. It's pretty old, I guess. It's 6 years old. Uh, Zumwelt. Good morning, Zumwelt. Where are you from? So, if nobody has really any specific interest, I think I'll just talk random. Okay. So, this batch. So who is using it? Let's see. Is there any actual company who is using it, and are they actually like what's their background? Okay, blah, blah, blah. Yeah. I don't think you need nobody. Nobody will need it. That is my guess. Okay, I don't know how they got 3.9 thousand stars and fork 181 forks. So anyway, so that's we need to find out about that, but I don't think I have interest to dig. So Zumwell says the wonderful shithole known as Florida. Okay, Florida is hot. Miami Vice. Zitron says, I don't know exactly, but can you talk a little about math? For example, fractals or other interesting math. Yeah, oh yeah, let's do that. Random, non-technical talk. Okay, let me finish about the bash. Not bash, but bat shell. Bat shell. Let's just call it bat shell. Stupid name. Okay, well, it's a mix from bash and batch. Okay, so I question the utility of this tool because in real life, in general, this is just my experience. In general, when you need to compile to both Windows batch and Linux, you don't do this kind of thing. Okay, you don't do this intermediate like, oh, convenient 1 2 solves your problem. That doesn't work in real life. This doesn't work unless you have actual some other stories bot. Okay, tell me, post it. This doesn't work. Okay, this nobody uses this. This is maybe for small companies. You know, some people maybe they think they save them some time, or maybe it's used by one single company. But anyway, because when in real life there are so many technical details, you cannot have this one installed script that compiles to both and expect it works so well on Windows and Linux. It doesn't. It's like it's kind of like today you have so many almost all languages compiles to JavaScript. Okay, and vast majority of them are just idiocy. Okay, they don't work in real life. They don't work. If you want to work in JavaScript, you dive into JavaScript. Develop JavaScript applications. Use Electron or whatever. You don't you don't use a generalized language that because you love, oh, I love Golang, therefore I'm gonna code everything in Golang and compare to JavaScript. This doesn't work. Okay, doesn't work because you will run into tremendous number of issues. In particular with DOM because okay, the only exception is that if the tool is designed from the beginning to work as a part of the web, such as ML. Okay, it's a good to mention ML. Now, wait, not ML, reasonML. Let me show you. Okay, reasonML. Now, reasonML is a version of meta language, which is ocaml. Okay, let me talk about the history. I told this story many times. So in the beginning, you have meta language, ML. Then you have camel. You have different variations. Camel, standard ML. Then you have ocaml from camel. Then you have fsharp from ocaml. Okay, so all these are the same, pretty much the same language, the same family. So then you have reasonML. So what is reasonML? ReasonML is basically OCaml, but in JavaScript syntax. Facebook created this. Okay, so that is about that, and I think it's a great language, but it's not very popular right now. So you can here's reasonML, and so I was talking about tools that tries to compile to multiple platforms, things like that, like the batshell thing. Okay, and I was saying it's similar in JavaScript land where you have so many languages, each one of them all trying to compile to JavaScript. Like you go to their website, you'll see they say, as a marketing, oh, we also have this version that compile to JavaScript, blah blah blah. That's bullshit. But however, what I was saying is that there are some exceptions. So what are the exceptions? If the language is designed from the ground up to work on the web, then that is good, such as reasonML. For example, reasonML, React.js, and Angular. Okay, I also count Angular, or uh, there are quite a few, or Elixir, Elm. Okay, I don't know if you guys heard of that. Um, Xali, proliferation of computer languages. So I'm kind of tired today, so I'm just going to do easy ranting today. like because when you do rant, you don't have to think you don't have to think a lot. So I'm just gonna do easy ranting, giving you guys my opinions. Okay, so opinions, guys, opinions posted. Okay, and rest. What rest? Okay, Bart was saying something. Okay, let me finish my thoughts. So you see F sharp, ML family. So ML family, you have F sharp, you have camel, you have Alice, you have ocaml, and you have F sharp. And by the way, you see these fear improving systems, Hall, Light, Isabel, Cock, they are all written in OCaml. Okay, so OCaml is very practical industrial language, far more widely used before Haskell became somewhat popular 10 years ago. The Haskell idiocy. Okay, so what I was saying So then you have concurrent clean. That's another functional language. Today's people, they don't know nothing. Today's people, Haskell people, they talk about Haskell monad every day. They know shit. Then you have Mercury, you have Q, you have R's. These are different languages, logic languages, and so on. But anyway, let's get back to I was giving you some get back to the previous topic. I was talking about how almost all languages today they have a version that they say they compile to JavaScript, and I was telling you they are shit. Okay, they don't work. Don't use them. And I was saying unless they are specifically designed from the ground up to be part of the web ecosystem. What are some such examples? Like I mentioned, reasonML, TypeScript, React.js, Angular. Okay, those are examples. And Dart. Okay, Dart is from Google. Now you can see pictures of them. And CoffeeScript. Yeah, so these are examples. These are tools that I would approve if you are a front end developer. I approve these tools. CoffeeScript, although of course I may not like them because some of them are old and stuff like that. So you have TypeScript, reasonML, React.js, Angular. You have Dart, you have TypeScript, you have ASM, and today you have WebAssembly, uh, and you have uh, wait, let's go. You have Elm, wait, Dart, TypeScript, WebAssembly. Uh, then you have Elm, which is also designed for the web specifically. So those are good. Okay, not Hex. This Hex is the opposite example, like where they try to like compare to every language. Like you just write in this language, it compares to everything. Shit. So let me give you some other examples. Elixir is a good example too, a good one for Java for compared to JavaScript because it is designed, from the ground up to be for as a web language, for as a JavaScript, uh, you know, either as replacement or compatible, like TypeScript. Elixir is based on Erlang. Okay, so you have these things, and pure script. Okay, I can accept pure script, And then you have cake ML, which is another branch of meta language, ocaml. So you have. So let me summarize. Okay, let me summarize what I'm trying to say. So today, almost all languages they have a version that compiles to JavaScript. Okay, now of them, most of them are just shit, no good. Some of them are good. Those good ones are those that 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 are designed to work as a web programming language. Almost the only goal, like you cannot use it for anything else. The only purpose for their existence is to use it as a JavaScript compatible replacement for the web. Those are good, and examples of those are reason reasonML, CoffeeScript, TypeScript, Dot, Elm, Elixir, uh, and PureScript, I guess, and okay, these are the examples. So if you want to do web dev, you you know those are I would think good choices. Okay, now all the other languages they all have a version to compare to JavaScript. Okay, those are all shit. Examples are, I would say, ClojureScript. Basically, all languages. Golang has a version to compare to JavaScript. Uh, Almost all of them. Okay, Rust. I don't know if Rust has a version for JavaScript compared to JavaScript. Golang has a kind of a project to compare to JavaScript. Uh, and those are all crap. Okay, don't use them. No good. So that is my point about that. Now back to the what I'm saying. So why is that? Why do I say some of these for JavaScript are good while all the others are no good? Because you have to look at their original design, their purpose. Many of them, for example, there's a ClojureScript, okay, or Golang. Julia also have a version. I believe I've seen Julia has a project, or either some of these are official, some of these are not official, like just by someone. So because they exist because the Golang, let's say Golang for example, or Scheme Lisp, there are so many such examples in Scheme or Common or Lisp community. They compare to JavaScript. They are all crap. Okay. Now the reason this group exists is because the programmers, the phonetics, they love the language, so they think, oh yeah, I love Golang, therefore I want to write everything. I want to also write JavaScript in Golang. That's what they are thinking. And that's the reason all these others exist. Okay, and that is also why they are no good, because when you actually work on big projects, serious project, all these fail. All these will fail. On the other hand, the those languages that's designed specifically for the JavaScript platform, for the web platform, those will be good. I mentioned many examples: TypeScript, Dot, Angular, React.js. Those are good. Okay, so that is my opinion about that and why and so on. Okay, I'm kind of tired, so I'm going to just rambling and rambling, and I guess you guys have to suffer suffer for my. So MC Reed, good morning. That there's shit, there's good, and there's solidly good. Okay. So, but what are you doing with this batch shit? What are you doing with it? Are you, like, okay, excuse me. I'm sorry for my intrusion of your private space and opinions. What are you doing with it? Okay, hold on a second. Bart answered something above, I think. Let's see. Uh, Ztron crazy. Great to see you. Oh yeah. So we Ztron crazy said we should talk about math, but okay. So what? How long have I been talking? 25 minutes, maybe another 20 minutes. So let's see. Ztron crazy. So Bar says, oh okay, yeah. So okay, so waiting for approval. No, I want it solved. My thread is not approved yet, but because ocaml fuck did not approve it. They did not approve it because you did something wrong, but I think I know you a little bit. I can kind of guess because you were, because, like, so you are, so if you are trying to, if you have a OCaml question, you have a question in some languages, you want it to be answered. So you join their group, forum, mailing list, or whatever. You post a question. Usually, it'll just be posted, and people will help you. No, but you are complaining. I can tell. Even from your style, even from the way you are, as talking to me about these things, you are not really serious about it. You are not serious about the question. It's not like if you don't get answer, you will lose, let's say, $10,000 tomorrow. Let's say by next week. Then you know what to do. You don't know what to do right now because this is not actually serious to you. You are just fucking around. That is why. Because if by next week you lose $10,000, then I don't have to tell you what to do. You know what to do. You will get your question answered on their forum. It will show up. It's not showing up because you are fucking around. I can tell. Like, okay, okay. They like, they didn't approve it. Why do they not approve it? Because you have some garbage in your post, probably, or something else. Something. Uh, so Boss says, is OCaml needed nowadays? Right now, I'm tempted to call it worse than C. What a garbage experience. OCaml. Okay, I haven't coded OCaml. Okay, so I can't say for sure, but I studied it for like a month or two, so I have kind of a beginner's tutorial. If you are interested, if any one of you are interested in OCaml, you might, it's good for beginners. You might try for the first, let's say, 3 hours, then you move on. So I don't know really. I was planning OCaml. I was planning for it to be my main language. This is about 10 years ago. You see, this is written in 2009, but I just never, things happens. I just never actually did much. So I spent 1 month in OCaml, and that's it. So I don't really know whatever OCaml questions. But however, I was thinking, I want to OCaml to be my main language to go to, is because I've read, all the opinions, and it's very good. Now remember, this is back in 2009, where Haskell is just beginning to become popular. By the way, Haskell is old. Okay, Haskell is like 30 years ago, 30 years old. Uh, I'm not sure it's older than OCaml or not. Probably not. Okay, but anyway, Haskell is pretty old. ML is older. ML is like 10 years older or something than Haskell. But Haskell itself is began. ML is like 1970s. Okay, Haskell is like 1980s. And Haskell didn't become popular until 2009 or something. So anyway, but by that time in 2009, OCaml is like, it's rather quiet. Okay, it's unlike Haskell, where every fuck young fuckheads, stupid people, programmers. Every day, you Haskell people. Oh, monad. Oh man. Oh, monad. Oh, you need to use Haskell. Oh, this is pure. Okay, it's not like that. Ocaml is rather quiet. You don't hear it. However, in 2009, there are lots of industrial strength applications. For example, the what's the application for downloading peer-to-peer software that download movies. Uh, the most popular one that's written in OCaml. Okay, Unison is also written in OCaml, the Unix tool. For a while, it's extremely popular. Okay, okay, we started to get into a lot of history. Unison. Now, if you don't know what Unison is like async, except it's two-way. Okay, both ways. So here's their logo. But however, they didn't continue. They kind of few people know about it today. But back then, like in 2000s, it was very popular. It's a two-way sync. It's a command line tool like rsync, the Unix Linux rsync. But Unison does both ways. You can update whatever is more current. So Unison, I used it, for many years, for 10 years, and it's very good. And Unison is written in OCaml. Okay, so if you want to look at, so there are quite a lot things written in OCaml. I'm not going to go into. You can, I think Wikipedia has, yeah, software written in OCaml. Okay, so you can see, uh, cock, yeah, cock. Almost all the math proof systems, cock, Hall, light, theorem proving systems, they are all written in OCaml. Okay, now those are serious stuff. And reasonML is a version of OCaml in JavaScript syntax. Okay, so that's why I have always been interested in OCaml. Just for some reason, I never actually, get on with it. So OCaml, I recommend. Yes, I approve. You have my approval. So OCaml. So what are we saying? So Unison. So what is written in OCaml? So you have, um, Facebook Messenger. Okay, that's kind of recent. Like in the Hex, the Hexy programming language compiler. Okay, Hexy, as we mentioned before, Hexy is a language that compiles to multiple other languages, and that is also written in OCaml. I didn't know. So where's this one? Has Hex. Okay, this is written in OCaml, and quite a few. So Whole Light, we mentioned Mirage, Opera, Tensor, Unison, 10 Cloud Platform, WebAssembly. The reference interpreter for WebAssembly is written in OCaml. Okay, so OCaml is solid. Okay, OCaml is truly solid, and far before Haskell came into light. And actually, I'm trying to find the peer-to-peer system. Uh, Called, what is it called? What's a peer-to-peer systems? For example, let's say in 2000s, you have many of them. Uh, okay, so Zitron crazy and hello beautiful people. So it's just bot talking, bot and Xa. What's a peer-to-peer system? For example, donkey. Exactly. Thank you, Matt. Donkey. That's the one I'm thinking. So donkey. Okay, now they have ML donkey too. Donkey. Yeah. So donkey is also donkey is the number one, the most popular peer-to-peer system. Okay, it's software that's written in OCaml. So So I was, OCaml in my opinion is very good, solid, industrial language. However, it's OCaml is like it's like PHP and JavaScript. It was quiet. You don't. It's because of the culture. You don't go there and you start to talk about monad. Everyone, you need to do monad. Did you do monad? Do you know understand? Do you understand monad? Like the Haskell fuckheads. Okay, so OCaml is by the culture community. It's kind of just quiet. They just do things. That is good. So why are we talking about OCaml? Because oh yeah, so Bart is asking me my opinion about it. Okay, so I do my homework and I'm not social. Oh, okay. Ztron crazy and okay. So what did Bart say? Let's see what did Bart say. So you are right. That's why I'm waiting approval. So now I want it solved. Okay, so OCaml, is OCaml needed nowadays? Right now, I'm tempted to call it worse than C. Okay, OCaml is good, pretty good. Okay, now as far as needed, well, nobody needs anything these days. I mean, there are so many languages, so it's up to you to choose. I mean, OCaml is one of the option, in my opinion. So yeah, so for those of you who constantly ask me which language to learn. Okay, OCaml is one of them, I would say. So you can study Golang, OCaml, JavaScript, Python. These languages I would approve. Okay, I would say yeah, go ahead, learn. I would like it. OCaml, Golang, OCaml, JavaScript, Python. I don't like Python, but it's very popular and useful in industry, especially if you need to get a job. Ruby is also good. Okay, it's just some choice. So OCaml, it's very good. Uh, okay, so what about let's see. OCaml needed. Okay, so you say batshell is bad, but what about bat? Rather learn batshell than bat. So what is bat? But but start yeah. So what is bat? So what is bat? Bat like Batman bat. Um, I don't know what bat. So Zumweld is from Florida. So maybe we can talk about math a little bit. So yeah, so I'm just gonna random talk and we're gonna shut down in 15 minutes, I think. So how are you doing? So today is Saturday. I guess Saturday is kind of relaxation day. Uh, so Bart says I was about to use it for a deployment thing at work, but then we dipped Windows support. We dipped Windows support, and I don't need it anymore. But am still interested in the language. Oh, okay. Uh, so you work in a company. So my opinion is just opinion. Okay, so I mean, you can So if you know your needs better than me. So if you so I don't actually know anything about this batch. So but maybe it's actually a good choice. So I don't know. Uh, and I haven't. Uh, so because I'm thinking if I'm in a company and like a small company, let's say startup, and then we need to write some simple shell script, installation script for both Windows and Bash. Then it's possible, I might say, oh, let's use batshell, maybe because I can then. But actually, I don't think that I'll do that. Yeah, today, if you want a universal installer, just go with Python Ruby. Okay, just tell your users to install Python or Ruby. Yeah, that doesn't work because typically the installer script, you don't want to tell people to install another system to install your system. So that is the reason why Bash is the most popular, script for installing programs on Linux, and on Windows. Well, on Windows, you don't use shell script to install things. You use the Windows installer. They have a framework. You use that. You have to do that. Um, so anyway, that's it about bad shell. Okay, I don't recommend it. It's a silly small language, and in today's world, you have so many other far more better and powerful and interesting languages than this bad shell. Okay, that's about that bad shell rant. What's wrong with Rust again? No, nothing. I don't like it because I don't like low level stuff. Hello, beautiful people. Yes. So Kathy asked about your uh, key mouse device. So okay. So boy 666 says, "Hello, have a nice day. Hello and a nice day. Can you talk about the math of non-repetitive tiling, Penrose tiling?" Okay, let's talk about math. Let's start there. So I don't know much about that subject, so I just rant, random rant today. I mean not rant, but random chat. Um, yeah. So, but you need to post the error messages. Anyway, Matt, you Matt can help you. Uh, Ditched. Cool, not always bad. What do you think about Electron? Electron. Well, they all, Electron is just. It's very complex. I'm trying to learn it. Ignore about those garbage rants on the web. Okay, that's what I think. I haven't read it. You posted a link, and that's a medium. So someone blogged about why electron is bad. I can guess. I don't need to read it because I know what they're gonna say. They're just some nerds. Electron. Yeah, it's bad, but it's kind of necessary, almost. If you want to talk about what's bad or what's not bad, don't use JavaScript in the first place. And in fact, don't do front end dev. Don't do web at all. That's the best. Okay, don't write any web application. That's the best. If you really, and these nerds, they opinions. Okay, it's just different opinions. If you want really great things, first stop. Don't do anything that don't create any web applications because that entirety of it sucks donkey ass. Not just JavaScript, but the whole DOM, the whole system is worst crap. And in turn, speaking of that, now if we actually get serious, we don't want garbage things. Then, Well, if we are talking about, you shouldn't write anything for the web, then you shouldn't write anything for Unix neither. So kill the entire Unix and Linux. Fuck. Okay, because well, if you ask my opinion, if you actually want to compare which is worse, the Unix ecosystem, the Linux, Unix ecosystem, every software, their culture, entire thing, all things considered, versus the web, the JavaScript complexity, the baggage, the DOM, extreme fact complexity, the DOM, then all this entire group of languages, WebAssembly and React, and the whole entire garbage. If you want to compare these two, I I think Unix is worse. Okay. Okay, tidings. Okay, I don't know much about tidings, so I'm kind of tired. So today random rant. Let's see. Tidings. Let's say something interesting about tidings. I did a talk about tidings before, and you were asking about non-periodic tidings. So the non-periodic tidings. Okay. Reading notes. Okay, let's. I'm just gonna talk some random things about tiding. Okay. I did write a lot about it, but I haven't been, doing it seriously for the past 20 years, basically. What is your problem with Haskell? My problem with the Haskell is the ignorant Haskell youngsters. That's my problem. Not Haskell itself, but the people. I mean, like today, like in the past 10 years. These idiot, I don't. It's not specific to Haskell. It's about this unthinking, trend following, full fashion, pop crowd type a class of programmers. These people I despise. Okay, so 20 years ago, they are chanting Perl every day. Perl, oh Perl this and that every day. And 20 years ago, this Perl fuckheads. Then you have, then you have then you have Python. Then you have many. Okay, but so Haskell is one of them. In the past 10 years, it become these young. There are a lot on Twitter. Okay, like they'll tell you what to do. They think they know better. Okay, they think they know functional programming. And they're gonna tell you, oh, Monad Haskell, and you see what usually happen is that they will go technical. Okay, it's like they don't know nothing about the world, you see. So here is the universe. Okay, here's we have the universe. It's this let's say it's this big. Can I see myself? Let's see. This big. Okay, this big. Okay, the big universe. Okay, now for average people, you live in this circle for basically all people. You can't, because the world is truly much bigger, the history and everything else. So you live in this little bubble. Everyone lives in here. We live here. Okay, this is our galaxy. This is Earth. Okay, we live here. Well, the universe is this big. So what was I saying? But we have these hotshots, from college. Typically, almost always young people. This almost always happens with young people, and logically too, because they are young. You know, college student or the smart. Like when I was young. Okay, when I was 20 something, I know everything. Okay, so these people, young people, so and they They read stuff and they learn, oh, Haskell is better because it's pure, it's referential transparency, oh, monad, oh, curving, oh, you got curving, oh, functional, no side effect, oh, it's based on mathematics, oh, it's algebraic types, these fuckheads, okay, these idiots. but so they are studious and they read a lot, okay, they are smart, young, uprising young people. So but they don't know how big is the universe. They don't know, and they don't know there are billions of people before them who are older, who have passed by, who you know like me 30 years ago. They don't know because they are young, they just woke up. They don't know, not they don't know they but they think they know because they read a lot and they are smart, and they are hotshot, and they are young, so they're gonna tell you, everyone what's good or what's bad. That's the thing mostly. And many of them are actually ignorant because, and Haskell, what a idiocy, the Haskell people, these young people. They know nothing about math, like nothing. They know nothing about first order logic, just seriously, not just, oh, I heard first order logic, oh, I took a class first order logic in college. These fucking idiots. They know nothing about it, okay, these Haskell people, but they chant about category theory every day. That's what happening, and before it was, then there's also Python people, then Lisp people, then before is Perl people. So that is what I despise. Okay, not because Haskell does any technicality of Haskell, the language itself. In fact, 15 years ago, 20 years ago, I was a fan. I was a fanatic of Haskell because it's a pure functional programming language. I'm not going to show my old articles, but that's my opinion. I never actually picked up Haskell actually. Uh, Okay, yeah, so I'm kind of tired, so it's just rambling. So about tilings and patterns. Okay, um, there is this periodic tilings, and there is this the most wonderful. Okay, this is the most wonderful book you should buy. Like, go out and buy it right away. Tilings and patterns. This is considered the the one and only, the biggest reference on the subject matter, tilings and patterns, the mathematical treatments of tilings. There are many aspects of it. There's geometric aspect, there's a symmetry aspect, there's a topology aspect. Then there's the math study of tilings. So this book was published in 1986. This is to this day, today, I'm pretty sure this is the only and biggest reference. So anyone who is serious about studying tilings, you should get this book. Now this book is out of print, so there's a new version. The Dover republished it. So, and they changed the cover to this trashy cover. Now this is original cover, classic. By Grumban and Shepard. So I talked to the authors. Those are mathematicians. They are very old, like probably 80s, 80 something, 70 or 80 today. But 20 years ago, I wrote to them. The Grumban guy, I think he is in University of Washington, and in fact, he's so nice. He's so kind to send me several of his. He sent me a stack of his publications. Let me try to get it for the show, since I'm doing a video talk show. Uh, there we have it. So in 1996 to 1998, I was diving into tilings and patterns. I'm writing a lot programs. So these are all my websites. I created them back then. And I was studying symmetry and tilings and stuff, toggle contrast, random. So I wrote this, and let me just show you some websites. So yeah, so remind me to show you the articles he sent me. So I was reading his book, and so here is my program written in Mathematica uh, for doing tilings. This is the best of out there. Okay, there are computer scientists who has also written related stuff. Programmers, I mean mathematicians, professors, and mine is better than theirs. I can tell you this plain tiling and Mathematica package. So I wrote this in 1997. So I was studying and I was reading this book. I still have this book. I did a video talking about that book actually. Actually, now I need to show it. Okay, let me show it. Remind me to show the articles this author sent me, this mathematician. Okay, hold on a second. Okay, it's so all very dusty. You see this? I don't know if you can see it's all dust. Actually, I cannot touch this book because it's so much dust. The last time I talked about this book is, I think, 4 months ago on video. So I still have this book. Ah, God, now I need to read it. I need to clean it. For some reason, my room is very dusty. I don't know where they came from. Dust. So in 1997, I was studying this guy's stuff, and I wrote him an email. I forgot what question I had. I forgot. But then, so he sent me these. Let me show you. Okay. So all these are publications of that guy in math journals. He has his own copy. Oh my God, this is thick. This is actually 20 pages. 20 pages. So this is Saturn and Trios, an introduction to the geometry of fabrics. Okay, in a mathematical investigation into patterns of weaving, revealing subtle stupid camera revealing subtle problems in combinatorics and geometry. So by Branko Grunham. So it's all math. I don't know if you can see it. You see, it's all patterns. Math study of patterns. Okay, very interesting. Actually, I haven't read it, but this is long ago. So he sent it to me. I wasn't asking for it. I think I was asking him some question. I forgot, but then he sent me to me like a collection of his papers in these math journals. I don't know if you can see it. Okay, let me try to. So this one is interlace patterns in Islamic Moorish art. Oh yeah, so I think I asked him. The question I asked him is about the relations between tilings and weaving. I think you see these many. Anyway, He sent me several of his publications, a copy of it. So now that was when I was younger, and now I end up being homeless and nothing. What the fuck? A sad story. Okay, so anyway, so now I end up a YouTube. I'm a YouTube comedian, guys. That's why I'm teaching. I'm teaching trigonometry online. Um, anyway, so yeah, tidings, a very interesting subject. Okay, I think that's it for today. That's closing down notes. So let's pick random. Now there's a very interesting thing about this. There is a tiding called Penrose tiles. Okay, let's go there. So you go to I don't know. uh I cannot teach you anything about it. I have some pictures, but let's go to Wikipedia. Penrose tiles, there's tremendous uh interesting thing going on. Okay, so let me leave you guys with one puzzle in math. Yeah, let me teach you something about math. Okay, so any questions? So I'm also young and I feel stupid because all this information I didn't found. I just learned from school, books or internet. What are tidings and pattern use and for? That's good. I've seen some of those tiles in Arab countries. Yes, they are famous for that because they, the Islamic religion, for some reason, forbid depiction of animals. That is why in Islamic churches you will see no animals and also no human figure because they don't allow it. So that is why in Islamic, how they call their church, how they call it, mosque or something, is you have all these tiles. So Penrose tile is invented by this guy. Penrose is a mathematician, physicist, mathematical physicist, and Penrose tile. Okay, the reason Penrose tile is interesting because it's a periodic tiling. Okay, what does that mean? Let me explain that, and that'll be it today. Okay, so and in fact, and Penrose tiling is one of the greatest discovery in math. One of the greatest. Is fairly important because the discovery of Penrose tiling kind of surprised everyone. So it's kind of a evolution, revolution, not evolution, but rather revolution. It made a wave in math community, and because it's like relativity, it changed how people think about. Uh, so it's a big theory. It's a big discovery. So a periodic tiling. So let me talk about. Let me tell you what that is. Okay. Again, I'm tired, so I'm not. I cannot do. Uh, I cannot. I cannot think. Talk about math properly. But let's try to show you random things. Why is there two copy of this page? Okay, close one. Uh, so I'm going to tell you about. Okay. So here is my notes. It's very incomplete. Okay, I mean it's not even beginning. about the math of tiling. So where how shall we begin? So first of all, yeah, let me tell you. Okay, so tiling. So let's go to Wikipedia. So because Wikipedia actually has the most information. So I'm going to tell you what is a periodic tiling. Then that will be it today. Ah, what the fuck is this? Biology, computing, people. What? Tessellations. Okay, stupid name. Tessellations. And I don't like the the phone version of Wikipedia. Fuck the phone version. Let's go to the full version. I don't want the phone version. Okay, that's better. So I'm going to tell you about periodic tidings and periodic tidings. Okay, let's show some. Okay, so here is a tiding. So this one is created by. So you see you have this shape and you just repeat it. Like a tile. You have a tile like a bathroom. A tile. You just repeat it. Okay, right, guys, right. So what time is it? So I've been talking. Oh, it's over 1 hour. So okay, so let me finish that. Five more minutes. So let's go back to. So you have a tile. You repeat it, and you can tile the plane. Now, this tiling is made by just one single shape. You see this one single shape. You just rotate it, and you can tile the plane. Okay, and when you have a tiling, when you use a tile to tile a plane, you call that tiling. Okay, so it's a tiling. So when you have a tiling, you can consider one of the questions to consider is whether it's periodic. A periodic tiling means that the whole thing can be repeated by moving it. So like imagine if you have a transparency of this picture. Let's see if I am showing you my screen. Yes. If imagine you have a transparency of this picture, you just move it up or to the side or in any direction, it will become itself. Okay, so mathematically when you move, we call that translation. So the tiling is a translation of itself. In other words, you can repeat the pattern by just moving it, by moving it straight lines. Okay, not rotation. Rotation is a different thing. Okay, so when you can do that, that's called periodic tiling because it's like a period. It repeats, but not rotation. Okay, remember that rotation is different. So now you understand what's a periodic tiling. And remember, this whole tile is made by one shape. Okay, that's another thing important. Let me show you. Let me talk about that. Now here is another tiling. Now this one is also periodic because you can just move the whole thing in a direction and it will repeat. The whole thing will repeat. Okay, so it's periodic tiling. However, now this tiling is made of two shapes. You see this large square and smaller square, two shapes to create this tiling. Now those shapes is called the prototile. Okay, remember that's a technical term when you talk about tiling in math, from math. Okay, so the shape that creates a tiling is called the prototile. Prototile. So in this tiling, it requires you need two prototiles. You have two different shapes to create this one. So let me just show you some other examples. Okay. So you've seen prototiles, and let's look at this one. Okay, this one how many prototiles are there? Can you say? Can you tell? This one requires one prototile. Just this one. So it requires just one shape. Then you rotate it and you can tile the plane. Now the question is this tiling periodic? Now try to answer it. Okay, you guys try to think about that and type your answer. Okay, so you have to think about it because you just listen, that doesn't do nothing. You have to actually think about it. So is that one periodic or not? Type your answer. Let me show you some other prototiles. Okay, they don't have. Okay, so let me show you. So this one. Okay, so wait. So let's look at some beautiful tidings. Okay. Yes, boy is correct. So that tile we've seen before, it's periodic. That's correct. Thank you for the answer. It's periodic because you can move it. No, it's actually periodic, guys. So you see, this is so that's why you have to think about it. You have to work out homework, okay? Because if you don't do, you just listen. You forget, and so this one is actually periodic. Now it's a bit tricky, but actually, if you look at in detail, if you actually try to think about it, you'll know because fundamentally it's basically based on a triangular grid. Okay, let me show you. Triangular grid. Once you see triangular grid, you'll understand why it's periodic. I lost my glasses. what? What? So we have a triangular grid here. Imagine this, right? So is this periodic? Obviously, this triangular grid is periodic because you can just move the whole thing. Then it repeats itself. Now this is also a tiling, so it's also a triangle. It's made of triangles. Now, if you go back to look at that one we were talking about, this one, you can kind of see it's actually based on the triangular grid. So you can actually move the whole thing and it will repeat itself. Yes, overlapping when translating. Yes. So I think they are first shape. What? Uh, yes, MC read. Yeah, you are right. So so this one is periodic. Okay, now let's talk about. Let me show you this. Okay, now this one is also periodic. You can kind of easily see. Now, but this one is got two prototiles. One is the hexagon, and the other one is a triangle. Now, if you don't count different colors as different, you ignore the colors for now. Now, colors are interesting because they change many other aspects, but however, we ignore the colors for now. So this tile is periodic, and it is made of two prototiles, one big hexagon and one small triangle. So you use these two shapes to create one. Okay, and let's show another example. Now this one is also periodic. It's like a triangular grid. It's periodic, and it has one prototile because you use one shape to tile it. So now remember two things. Okay, let me summarize. The concept of when is a tiling periodic. Now you have to remember to give a definition. When is a tiling periodic? Okay. The other concept is a prototile, which is the shape or more than one. The shape that is used to tile the plane. Okay. Okay, that's a two thing. I hope you will remember that because that's part of the important concept if you want to study the math of tidings. Now let's look at this one. Now this one is very interesting because this one actually, oh, it's so big. Let's shrink. This one actually also tiles the plane because you can see these two things repeat and you'll tile the plane. But is this one periodic? Now answer. Okay, try to type that in the okay, yeah, you are right, boys. But anyway, let's think about this one. This one is this one periodic or not? And this one, but this will tile the plane because you can see it grows outside. And this one has only one prototile if you ignore the color. So one prototile to tile the plane. Okay. Anyone answer the question? Is this one periodic or not? So Bowie says no. You are right. It's it's not periodic because you cannot move it by a straight line to have it repeat by itself. You cannot. However, it can repeat by itself if you rotate it, but that's not the definition of periodicity. That's symmetry. That's rotational symmetry, which is important, but that's not periodic. Okay. So periodic means it repeats by moving by like period. Okay. So periodic or not and prototile. Remember these two things. Okay, so now we are going to talk about a periodic tiling. Now, who asked the question? I'm probably talking too basic about because whoever asked about Penrose tiling, he, the person already know what it means. Uh, you know, but anyway, I'm just giving you, people, most people who don't know about this. So now remember, okay, periodic tilings and prototile. Okay, so that's the two things you want to remember. Now let's go back. Let's talk about a periodic tiling. Okay, let's just go to Wikipedia because they have the most good information. Okay, this is beautiful. Now this is a instance of Penrose tiling. It's beautiful. Now remember the question. We talked about the concept of. Ah, hold on a second. So let me go to. Remember we talked about the concept of whether a tiling is periodic and the prototiles of a tiling. Okay. Now let's look at some examples. Okay, here's a question the mathematician wants to answer, and to this day it's still not completely solved. Okay, the question is it possible to have a prototile, a shape or a set of shapes? Let's say just a shape. Okay, is it possible to have a shape, a prototile, such that the shape can tile the plane? However, it can only do it in a way such that the result is not periodic. Does that make sense, anyone? Okay. Oh yeah, boy. So boy is about asking about the parallel of symmetry groups in Penrose tiding. The Yeah. So I don't know that answer. That's that's advanced question. I don't know the answer. I studied this. I never studied much about Penrose tidings. So yeah, I don't know answer to your question. So anyway, back to the general general education. So the mathematician wants to know, is it possible to have a shape or a set of shapes such that they will tile the plane, but they can only do it in a way that the result is not periodic? And the answer is yes. And in fact, we have seen the answer. And that answer is uh, that answer. Wait, is this also count as the answer? I don't know. Anyway, let's. The Penrose tile is one such solution. So it uses two shapes. One is like that. One is like two rhombus like shape to tile the plane. However, the only way you can do it is by creating a pattern that's not periodic. Now, there are some complexities in this because this is not actually the shape you use. The actual shape is actually, that requires some explanation, Penrose tiding, because the actual shape for Penrose tiding is actually, you know, the shape is actually more complicated. It's not just rhombuses. However, you can, like a jigsaw puzzle, you can carve holes into it so that they only fit in one way. That's a real shape. But however, we kind of ignore that because um, I don't know if you guys know what I'm saying, talking about. Anyway, that I think that's it for today. Uh, so you can now you can read Wikipedia. Okay, so here is an example. Okay, here is a real Penrose tiles. So with these two shapes, or you call them prototiles, with these two shapes, you can tile the plane. Meaning fill the plane to infinity. However, it's not possible to do it in a way that the result is periodic. Okay, so that is a solution. This is one of the solution to the question, and this is not the only one. You see, before Penrose tile, mathematicians has come up with other solutions. For example, let me show you. We've seen it here, but I just scored off. Anyway, we've seen that. It's called Wang tiles. Okay, let me show you Wang tile. And this subject connects to formal logic, connects very deep, connects to formal logic and the heart of computer science, theoretical computer science. So this Wang tiles, in the beginning, it's like hundreds of tiles. So you need these hundreds of shapes to tile a plane, and they can only do it such that the result is not periodic. I think that's the okay. I think that's what it is. Don't quote me for it. I don't remember. I'm no expert. Anyway, so the answer to the mathematician's question is yes. It is possible to have a set of shapes, one or more, such that finite number of tiles, such that they can tile the plane. However, they can only do it in a non-periodic way. Okay, that is possible because, for example, here's one example, And then we have Penrose tiles. That's another example. Okay, and but however, is it possible to do it with only one single shape, one single prototile? I think that question is not solved. Okay, I think that question is not solved. I think also there's another requirement is that they require that the tiling be not symmetric. Okay, so this one doesn't count. They require, because this one, the result is symmetric, meaning that there's a rotational symmetry. You rotate it, it becomes itself. Uh, anyway, that is about that for today. Thank you guys. So Boy says I'm called the uh, Einstein problem. It's called the Einstein problem. For now, it can only be solved by mirroring the tile or by using a disconnected tile. Okay, so let's see what is the Einstein problem. Einstein problem, let's look. This would be interesting. In plane geometry, the Einstein problem asks about the existence of a single prototile that by itself forms a periodic set of prototiles. Okay? Forms a periodic set of prototiles. Okay? Okay. So that is shape that can tessellate the space, but only in a non-periodic way. Okay. Yeah. Okay. So the question I just talked about is called Einstein problem. So Boy, you know a lot math. Are you a mathematician? Because my followers, they are very diverse. Many are young people, but some are mathematicians. Some are about the same age as me. So I'm talking, and sometimes, the subject is too simple. So anyway, so let's see. Such a shape is called Einstein, not to be confused with Einstein. Okay, a play on German word Einstein. Okay, one tile. Okay, stupid name. The Einstein problem can be seen as natural extension of the second part of Hilbert 18th problem. Okay. Yeah, I haven't heard of this name. Interesting. I should have. Okay, that's it for today. Thank you guys for watching. Bye, guys. Study math as a hobby. That's great. Me too. And in fact, when you study tidings, there are quite a few mathematicians, hobbyists, without even knowing calculus. They have created theorems in tiding, just by, because tiding, the math of tiding is a subject, it's not mainstream. Okay, if you go to university, you want to become a mathematician. So you go to college, you study calculus, linear algebra, differential equations, complex complex analysis, topology, differential geometry. You go on, you get a PhD, and algebra, group theory, field theory. You become a mathematician after you got a PhD. But you may not have studied tiding. You will know nothing about this subject. This tiding thing is not mainstream. Okay. Well, if you are a good mathematician and if you are curious, of course, you will have learned it by your own in your journey of studying math. But anyway, so this is not the mainstream math. One like combinatorics, graph theory, projective geometry. Those are not mainstream, including the tiling stuff. So, and tiling thing is very appealing to the mathematicians because you don't need to know calculus. You don't need to study 2 years of calculus just to understand what this is about. You don't need to, because I just explained to you in the past 30 minutes what periodicity means. So So you might start to do something. It's fun. Oh yeah, here is an example. Robinson tiles. Here's an example of non-periodic tiling. It's called aperiodic because when a set of tiles they can tile a plane, but only in a non-periodic way. You call those tiles a periodic tiling. So here's the example. So anyway, so it turns out there are quite a few non-mathematicians. Like they don't even like they are housewife. They don't have a college degree, and they have found new theories in tiling. For example, let me show you uh, here. Okay, in 1990s. Okay, when I was studying math, this happened in 1990s. So the question is here. The question is you want to. Okay, so you see this bunch of pentagons. They are a shape of five sides. You want to create a tiling using this shape. So tiling by pentagons. Okay, that is the problem. But the problem is actually to list all possible such tilings. So you want to have a complete list of pentagons that can tile the plane. You want to have a complete list. So this is the problem. And there are the mathematician. Her name is you read this article, you'll find it. But I have to. Okay, 1975. Rice. Okay, this housewife, Marjorie Rice, her in 1977. She discovered four of them. Never studied, never known before. She discovered four of them. Then later other people showed more. Then by 2015, just 4 years ago, they discovered another one. And today I think it's proven that we have the complete list of them. So this problem is now solved. Anyway, in tiling there are quite a lot unsolved problems. It's easy to understand. Now look at these. Some of these are just beautiful. You see, another interesting thing is that when you have a tile, sometimes a set of prototiles, you can tile the plane in more than one way. uh, you know do you see what I'm saying? Like you arrange this way, that's one configuration, but you can arrange in another way using the same tile and it looks different. So it's extremely beautiful. Okay, bye guys.